Testing is fundamentally a human social service that we provide to teams, organizations, and to society, right? We are here to help people avoid getting hurt, to help people avoid loss, harm, damage, bad feelings, loss of reputation, loss of money, loss of opportunity, loss of freedom. I think over the next 3 to 5 years, one of the things that we're going to have to deal with is the fact that we are in a socially and politically extremely turbulent time. And there are very powerful forces that are trying to essentially make sure that people who are already insanely rich get more rich. And this is not a political rally, much, but I'm getting old enough now that I grew up in a very optimistic time when it looked like a lot of unfairnesses and a lot of serious social problems were on their way to being solved. And in my lifetime, we've made enormous progress on that. Enormous progress. Not enough, but significant, enormous progress. We've got to focus on that kind of risk. Technical skills are really, really important for testers, but that's not the most important thing to me. You can be a fantastic tester by being a really good journalist. Aline, who is in the class this week, has that kind of background. By being an observer of the dynamics of how software is put together, by being a risk investigator. We've got to focus on risk. And if you are inclined to learn technical skills, if you're inclined to learn to be a programmer, if you're to learn how to code, it's not that hard to learn how to code and to help you do useful things. But if you don't want to be a coder, as James puts it, you have another option. You don't have to learn to code. You can be charming. And you can charm the people around you because there's lots of people on the project who already know how to code. You can enlist their help and provide them with the help they need in order to recognize risk and problems. The coding part of that, relatively speaking, might be kind of easy. Relatively speaking. It's not trivial, but it can be really, really hard, I think, to teach somebody who is not empathetic and not risk-focused and not a great critical thinker. It can be really hard to teach them how to do that. It can be relatively easy to take somebody who is good at those things and get them to learn the code, or to get them to learn how to enlist the aid of other people who can code. Oh, well, in terms of teaching my classes better, AI produces a fabulous bed of erroneous, crappy software. Data that makes no sense. It provides wonderful examples of that. I'm being only a little bit flippant when I say that. I believe pretty strongly that it's something that didn't come up in what I was talking about in the presentation. One of the things that you desperately need when you're using these tools is to be what Harry Collins would call, fancy term alert, the legitimate locus of interpretation. In other words, and we had a nice conversation about this earlier, you need to be sufficiently expert, sufficiently skilled in order to evaluate what you're getting from this thing, in order to notice the problems and the errors in it. Books and examples that are out there on the web already that have been curated by people at least have that somebody looked at it, somebody developed it consciously. But everything I get from an LLM, I know this because this is how they work, is being generated spontaneously on the spot. And it's done so without its own sort of sense of self-evaluation because it doesn't do that. That's not what they do. They don't know the difference between right and wrong. There's no knowledge involved at all. It's generating a set of strings. So what I could say is I can look at this and reason about it and say, is this a good answer? Is it not a good answer? And why do I think it's a good answer? Or why do I think it's not a good answer? That's a sort of interesting application of it. My experience, though, is that every time I've tried to use it to develop a bit of code, it does something. Sometimes it doesn't. I put it in the fire it into a file, and I run it. It's a Python program, and it crashes right away. Ugh. Okay, so maybe I run it, and there's a library missing that I actually need. So pip install, what have you, and I run that. Sometimes I run it, and it doesn't do the thing that I wanted it to do. Because an example I had the other day is it moves a list of files, it gives me a list of files, but it leaves off the file extension. It has these sort of embarrassing things. Whoa! But sometimes it gets it just right. But then I have to wonder to myself, what might it not be getting right that I might not be noticing? So to be not too flippant about it, what I get from it is, what might be wrong about this program that has been generated, or what might be wrong about this data that's been generated? It gives me, I'm on hyper alert when I get that sort of stuff from an LLM. Other than that, in fact, just today, Satya Nadella, the head of Microsoft, finally owned something that I believe is actually true. That, okay, AI isn't exactly at all improving productivity. And we gotta look at that. What really is going to be beneficial is the fact that population or the world is growing by 10%. That's the real success of it. And I look at it and I think, well, dude, where were you 18 months ago when we were telling you that? So. I have to push pause on something because those of you who are familiar with me, bear with me because we have this always has to be done retail. It can't be done wholesale for some reason. In 2009, I started making a distinction between testing, which is, as I described, evaluating a product by learning about it through experimenting and exploring and experiencing, and checking, which is the process of applying algorithmic decision rules to output from a program, and then relaying the output or the outcome of those decision rules to a human for evaluation. A check is always embedded in a test, right? So when we're talking about a test is not something that you write. A test is something you perform, and there are bits of things that automation can do, code can do, in order to do stuff in the middle part. This is important because what you're identifying here is the gap between your intentions and the things that the machinery can do, which is in the middle, and then at the end, the interpretation the evaluation of what happens. Here's why that's a big deal. Because if you run a bunch of automated checks through your process of building your product, and one of them runs red, you don't go to the programmer and say, there's a bug in your code. You have to investigate it, and you have to evaluate what's going on. You have to figure out why the check is running red, because it might be a bug in the check code, or it might be a bug in the environment, or a problem in the environment, or an inconsistency, something not set up, something that's supposed to be there, the database wasn't ready, that sort of stuff. You don't go to the programmer and say there's a bug in your code. You have to investigate it first. So the process of creating what you're talking about, which is a suite of automated checks that you put into the build, has this intentionality at the beginning of it, where you identify a risk that you want to check for, and you go through the process of encoding that. And now we're getting into the gray area where you're saying, could I get a GPT to create the code for that? What I worry about is fixation, because I mentioned this as an issue, fixation on the idea that once a problem has happened, it's going to come back somehow. So now that is a possibility, don't get me wrong. However, I also want to ask, is it really helpful to put up yet another smoke alarm when the problem is not that there's going to be another fire in a particular room? The problem is there's really flammable building materials that have been put into the thing. There's people smoking in bed. There's oily rags sitting in the closet. And there's also these dudes walking around putting buckets of gasoline down and casually throwing embers into them. That is something where I think the software development community is really, really slow to do things in ways that the airlines have decided something. They decided in 1985 or so that because there were 5 major airline crashes every year where hundreds of people would die, they decided, we actually should be learning from this experience. And so with the regulators and with the investigators, with the aircraft manufacturers, with the airlines themselves, with the training protocols, they made this resolution. We shall learn from every bug. And so they put things into the testing of aircraft, and a good friend of ours is a tester of the simulators for the Boeing 777, or at least he was. Coolest testing job ever, because the job is so complex. How do you get the skills for that? Well, you start, in his case, by being a Boeing 777 pilot. And you need that kind of experience to do that, because there's 1 million parts in the there's 2 million parts in the plane. There's 1 million of them in the cockpit, and he has to know about every single one and how they might have an effect on these systems and so on. He has to know how the simulator is going to reproduce exactly the conditions, including the physics and the layout of the displays, so that within 6 months, if there's a change in the physical plant at the airport, it's got to be reflected in the graphics that the pilot sees. All that stuff gets poured into these simulators. Why? Because they want software, hardware that reproduces precisely all the things that we need to do to train pilots. Okay, so the airline industry has this incredible record. Now, there are occasional problems, and in fact, the reason that the story with the 737 MAX 8 is such a big deal is because Boeing forgot all the things that it had learned. There was an executive at the top of the company and permeating all the way down who said, you know what? We can get away with this. We can create a new airplane with new avionics on it and this new system called MCAS that if we do this really well, and if we get a bunch of the regulators to come work for us, we won't have to do pilot retraining on this system. So instead of getting retraining, what the pilots got was a memo. Oh, there's this new thing called MCAS, and you have to respond to it. Well, the software business is not like that. The software business has not yet learned to learn from every bug. And so we have this fixation, this obsession with regression problems. Why? Because there's so many of them. And we've decided the way we want to handle that is to essentially have a bunch of barn door closers who come around and make sure, is the horse still in here long after it's left the building? So what I would counsel is to ask ourselves, for a check like you're talking about, where there's a button that didn't show up on the screen, putting in another automated check is not a terrible idea, but how many hundreds of thousands of them do we need in order to recapture and revisit and recapitulate all the problems that we've seen before? But here's the thing. Let's remember that one of the things that testers can do that really, really helps is not only to identify problems as they arise, but to consider, wait a minute, where do the problems come from? And what could we do that's even less expensive than an automated check? Here's why that's a big deal. Supposing we got 100,000 checks that run on every build. How many checks do we, wouldn't that be great? How many checks do we have to review every working day of the year to review each one of those checks once a year? Oh, no, we don't do it only when they fail, because they could be running green and fooling us. Green's always fine. Green basically means the dog didn't bark, right? We would have to review 400 checks a day in order to review each one of those checks once per year. Now, if that's the case, what's the possibility that one of those green checks is fooling us? That hundreds of those green checks are fooling us because they haven't been looked at. So I actually want to reduce the number of automated checks that I perform, because we could reduce them greatly with review, pairing, shallow testing, shallow checking that's being done at the developer level, where the developers themselves are looking at their own code, their own work, such that the button problem reappearing, the odds of that disappear. Focus on risk. Focus on problems. Focus on trouble. My friend, former student, now colleague, in many ways colleague who has surpassed the teacher, Adam White, had this beautiful thing on his resume when he was applying for a job as a tester in 2009 or 2010 or something. It said, "Preventing surprises since 1999. That's what we're trying to do as testers. We're trying to help people anticipate and to some degree prevent unpleasant surprises. There's another thing, though, that I think I would like to focus on, and that is, it's related to the testing and checking thing. It is important for us to check the output from functions, because if the functions don't produce correct output, some requirement or another will probably not get met. Right? The functions are there to enable a requirement to be fulfilled. That's asymmetric, though, because just because a function produces correct output doesn't mean that a requirement will get met. And I think a lot of testers have been diverted from considering, does this product have a problem meeting its requirements? They've been diverted from that to, are the outputs from these functions correct? And that's a big problem associated with the, I'm want to be a little bit whimsical about it, but I kind of call them the CI/CD Maoists who say that, well, as long as the checks in the build pass, then it's ready to be deployed. I say, as long as the checks in the build pass, it's ready to give to a tester to kick the snot out of it and see what might be there as problematic. Because again, that issue of emergence that happens when beautifully checked components are put together and they produce something that doesn't fulfill its requirements. So focus on problems with meeting the requirements and do not be distracted, although it's important, do not be distracted by correct output from functions, because there's an asymmetry there that we need to be careful of. I did a short video on that subject called The Real Requirements. People talk about functional requirements and non-functional requirements. I think that is such a catastrophic misstatement, the wrong way of thinking about it. We have functions that we got to check, and their requirements have to be fulfilled. But if the product doesn't fulfill its requirements, then the product doesn't work in some sense, right? The product, there's a problem with the product. But what we call non-functional requirements, those are the requirements. The functions are essential because they enable the requirements to be met, but let's not dismiss everything that the product has to do by calling them non-functional requirements. It's like calling them, there's two kinds of trees, Christmas trees and all the other kinds. You will have no problem dissuading them from foolish choices when you have an excellent reputation. In this business, in the business of testing, your reputation is everything. Yeah. Nobody says to a plumber, I've got a really good idea for you to handle some aspect of the plumbing. When they invite a plumber into their house, it's because they're saying, I need a professional plumber. And what is easy to do for some kind of executive or some kind of manager or some kind of developer, it's easy for them to think testing's easy. Know why? Because nobody ever sat down in front of a keyboard and a screen and went, oh my goodness, I created a web browser by accident. What do you know, right? Nobody's ever created a product by accident, but people run into bugs by accident all the time. Therefore, they think, well, finding bugs is easy. I find them every day myself. The question is, do you want to find bugs deliberately, intentionally, quickly, expertly, in many, many, many different elements of the product, in many different factors of the product? But I think there are, sad to say, lots of testers who do not have a good reputation. And I think that not so good reputation is, I'm sad to say, justifiable because of a whole decadent kind of culture we've got where testing has been reduced to interacting with the product directly by following a script and by complying with what it says in the script and seeing the outcome of a set of steps that you're supposed to follow. And if you see the right result at the end, put a little green check mark beside it. And if you get something that's inconsistent with that, you put a little red X, and that's that. Rather than what I would consider to be a much better assignment for a tester. Rather than say to the tester, do this, do this, do this, do this, then look at that X or check mark. What I would say to a tester is, here's a product that's intended to do something. Here's some requirements documentation about it. Here is somebody who is expert in the domain in which this product is intended to be used. You can make friends with them if you like, but try to use this product to get something done. And I want you to report to me anything that you find confusing, frustrating, wrong, exasperating, annoying, incomplete, inexplicable, anything where you see there could be a problem for some other person who might be trying to get value out of this product. If we establish that as a tester's mission, rather than saying do this, and then do that, then the tester gets a chance to exercise his or her learning process and his or her expertise. So the reason that testers, a big reason that testers have a poor reputation is because essentially the business has demotivated them from doing good testing work because they haven't given them that kind of assignment on the one hand. And on the other, the testers can sometimes orient themselves towards trivial problems that don't actually amount to a risk for the business. So be a risk investigator and develop a reputation for being a risk investigator and a critical thinker. Somebody who's focused, somebody said at the beginning, get involved early on if you can, and if you're not asked to involve, barge your way in and help the business to answer about 5 questions all the way through. What are we building? Who are we building for? What do they want from it? What could go wrong? How would we know? The last 2 questions, what could go wrong and how would we know? Nobody but the tester is going to ask those questions as their first item of business at the meeting. Then go around again. What else are we building? Who else are we building it for? Because there's always more than one. What else do they want from it? Because there's always more stuff than the one thing that the developers and the designers and the testers or the developers, the designers, and the managers are focused on. There's always more than the thing that they're attending to. There's other things that they're not attending to. Even great designers might miss, performance, right? Compatibility with other stuff, right? So our job as testers is to help people understand what they might be missing, the things they might not be seeing. And then, third time around the horn, what are we not building? Who are we not building it for? What do they not want from it? What could not go wrong? And as soon as you ask that, somebody says, this couldn't go wrong. And somebody else will say, actually, I can think of a way that might go wrong. How would we not know? What things would be throwing mud on our windscreens and on our headlights and on our dashboards? How would we be unaware of a problem? If we establish a reputation for getting those questions out in front of the business real early and all the way through the project, then we will develop a reputation as risk investigators and as problem identifiers, which is our primary contribution to software development. If it's not exploratory, it's not testing. That's how I answer that question. If you're not learning something new, if you're not exploring new territory, it's not testing. It's demonstration, it's confirmation, it's something else, but it's not testing. To test is to challenge. To test it, and this is something which actually hasn't come up so far tonight, but I think it's a good thing to remember. It's tempting to say that we're testing the product. And, to a certain degree you are. We're challenging the product to do something. But as testers, what we're challenging is more than anything, beliefs about the product, assumptions about the product. And in order to do that, we have to explore those assumptions. We have to explore those beliefs. We have to talk to people about what they believe. We have to ask people about what they want from the product. That's an exploratory process. All that stuff that people talk about that they say is testing, that rote, repetitive stuff that is what I would call automated checking, most of the testing stuff has been sucked out of that, right? Because mostly what we're doing there is by rote, by repetition, we're trying to confirm things that we already knew or believed to be true. So what I want to do as a tester is I want to find things that no one else has noticed before. And you can't do that without exploring, not effectively. So that's my answer. If it ain't exploratory, it ain't testing. It might be something else, a little marginally useful, but if it ain't exploratory, it ain't testing. People say that exploratory testing is an add-on. You know, we do our testing and then we do exploratory testing. It's the opposite way entirely. The script is the guest in the house of exploratory testing. And sometimes the script is a guest that's been around too long and hasn't bathed very well, you know, hasn't washed. And it's, you know, it's like the Oscar Wilde thing about guests are like fish. You know, if they're around for too long, they start to smell bad. The script is the foreign agent inside the house of testing. Exploration is the homeowner of testing, and scripting is a guest that is occasionally welcome. Because where do scripts come from? They come from exploration. What happens when we investigate a bug that we've never seen before? We explore. We have to do that. The investigation part is not covered by a script. There's no script that tells you how to investigate a bug. There's no script that tells you how to have a conversation with a developer about a bug that you've just found. Scripting is the guest. Exploration owns the house. Testing like a user is really important, but it's only part of testing like a tester. Because there's stuff that we can find that no user will ever find intentionally, deliberately. They'll just find out about it when their data gets lost or when the task that they want to accomplish is blocked. They'll find out about that by accident, but deliberately looking for problems is a huge part of that. And to look for them, we have to explore.